This call is now being recorded.
ഓക്കെയാണ് സാർ, ഓക്കെയാണ്.
ഓക്കെ സാർ.
സാർ അപ്പോൾ സ്റ്റാർട്ട് ചെയ്തോ? സാർ ഫോണിലായിരിക്കും.
ഓക്കെ സാർ. Can everyone hear me?
Yes, sir.
Yes, sir.
Okay. So I'll be teaching you automobile engineering. It's an elective subject in your branch. And myself, my name Melvin Philip Matthew. I am newly joined in your college, and I'll be teaching you automobile engineering. I have completed my BTech studies from Avalajodi College of Engineering, and I have done my MTech from St. Joseph's College Engineering, Pala. And I had just now joined your college, and I will be unable to come to the college right now, but we are handling online classes. And we will deal for about a month, we will be dealing in online classes, and then thereafter we will do contact classes. Okay, in your module 1, we have a few topics dealing with engine components and their working and their materials used for its constructions, and we will be dealing with that. And beforehand, I would like to know what all you know about the engine side of, the automobile side of your branch studies. So anyone can tell me what is an engine and what have you studied previously about engine? Anyone please unmute and please tell me about the engine. Am I audible? Hello?
Yes, sir.
Yeah, please tell me what is an engine. You can say it in your own words. No need for any definitions or anything. Just tell me what you know about an engine. What is an engine? Hello? Can anyone say me?
Sir, a machine with the moving parts.
Okay, it's a machine with the moving parts. Okay. Any other examples or?
Sir, engine conversion ഉപയോഗിക്കുന്നതാ.
Okay, conversion of what actually?
Power to motion.
Power to motion. Okay. You have told me some basic examples. So basically an engine, can everyone see this? Is it visible?
Yes, sir.
Yes, sir.
Okay. So basically an engine is used to convert one or forms of energy into mechanical energy. Okay. An engine is a device or a machine that is used to convert one or more forms of energy into mechanical energy. So we have one type of energy, that is basically we are using heat energy, that is a combustion of a fuel. We'll be learning about that in detail. Okay, and heat energy obtained from the fuel such as petrol or diesel is used for running an engine. That is, we are giving an heat energy, and that heat energy will be converted into mechanical energy. Okay, a mechanical energy such as in cars, when you see in cars, the mechanical energy is in the form of the running of the wheels. Okay, what you do for propelling a vehicle, we are using the mechanical energy generated from the engine to the wheels. That is what is done in an automobile. So an engine is actually the powerhouse of a automobile or any such propelling vehicle. Okay, any propelling vehicle. An automobile is any such device that is used to propel. So to propel, we have cars, we have trains, we have aeroplanes, even rockets. These are all propel. It's an automobile. They have a propelling motion. So to propel this, they use engines. So different type of engines are there. So I have given here a few the pictures of certain engines. Can anyone tell me what are the engines shown here? There are three type of engines shown here. What are all the engines shown here? What is the first engine? Am I audible? Can everyone hear me?
Yes, sir.
Yes, sir.
Okay. Okay, please tell me what are the three engines shown here? Anyone? Anyone can tell me? The third engine, at least. We have seen
Jet
what is
engine.
the third.
Jet
Yeah,
engine.
it's a jet engine is shown in the third one. Anyone can tell me what is the first engine shown here?
So steam engine.
Yeah, it's a steam engine. Okay, where is a steam engine used?
Locomotives.
Yeah, it's used in locomotives or trains. Okay. The second engine shown here is the actual IC engine, or what we have seen in automobiles. Okay. So there are three types of engines here shown. Okay, there are a few more that is shown here. I'll tell you which are the ones. The first one shown here is the turbine engine, a gas turbine engine, which is used in aeroplanes. Aeroplanes use a gas turbine engine. In the second diagram, you can see a rocket engine that are used in a rocket. This is a Raptor engine. Raptor engines used in SpaceX rockets. So it's a rocket engine. The third one is a train that is fully powered in electrical side. So it is called an electrical engine. Okay, electrical engine for locomotives, and also it is used in cars. So it is also called as an electric cars, are also called as an electric engine driven cars. Okay, so those are another types of engines. Then conventionally, before the rise of technology, there were some engines. They are called as physical engines. So these engines do not obey any chemical reactions or conversion of heat into mechanical energy and such on, but they follow physical laws such as physics, due to physics such as gravity or a spring motion due to potential energy. So such engines are used for physical engines. So we'll discuss what are the types of engines. So basically, engines are divided into three types: thermal engines, electrical engines, and physical engines. Thermal engines are subdivided into internal combustion engines, external combustion engines, and reaction engines. So I'll give you a brief description about this. So basically, a thermal engines are known as engines that converts heat energy into mechanical energy. They convert the heat generated due to the combustion. Combustion means burning of fuel. While we burn, we get heat energy, and that heat energy is converted into mechanical energy. Such engines are called as thermal engines. So before I show you three pictures, and they are all thermal engines. A steam engine is a thermal engine, IC engine is a thermal engine, and also a rocket engine is also a thermal engine. We use the heat energy for doing the mechanical work. Rocket engines are also there. Aeroplane engines are also part of thermal engines. Then basically what is an IC engine? IC engines are also known as internal combustion engines. The name suggests internal combustion engine. So an internal combustion engine says that the engine combustion takes place inside the vehicle or an automobile. Inside an automobile, the combustion takes place. Such engines are called as internal combustion engine or IC engine. The fuel is burned inside a specialized area of the system called combustion chamber. So there is something known as a combustion chamber, and inside the combustion chamber we burn the fuel, and the fuel such as petrol, diesel, or we have biodiesel, even rocket fuels, such as even water, that is steam engines use water, that is as in steam. So there is a combustion chamber, and inside the chamber the working fluid such as petrol, diesel, etc. are used, and they are burned inside a combustion chamber, and the combustion chamber produces heat energy. Inside the combustion chamber, heat energy is produced. This heat energy is in the form of an explosion. That explosion propels the piston or any other mechanical part to do mechanical work. So an IC engine figure is given here, and in the right hand side you can see a working of an IC engine. So in an IC engine you can see there is a moving part shown in gray color. Those are known as pistons. Okay, the piston, the movement of the piston turns a red part. The red part shown is called a crankshaft. Okay, the piston's movement causes the crankshaft to rotate. Okay, the piston moves in a to and fro motion, that is upwards and downwards motion, and that is converted into a rotational motion in the crankshaft. The to and fro motion of the piston is transmitted and converted to a rotational motion in the flywheel. Okay, the crankshaft is connected to a big wheel. You can see a wheel at the side of the engine, and that wheel is known as the flywheel. The flywheel is like a gear, and it transmits the energy to the wheels. Okay, there are certain components in between, but just know that the flywheel transfers the energy to the wheels. Okay, the energy that is obtained inside the combustion chamber is a heat energy. That heat energy is converted into that explosion. There is an explosion occurring inside the combustion chamber. That explosion propels the piston downwards. Okay, there is an explosion happening inside the cylinder, and that explosion propels or throws out the piston downwards, thereby giving us that mechanical energy. Okay, that energy, then we get a rotational motion. That rotational energy is then transferred to the wheels. So an IC engine, this is the basic working. So in the working process of an IC engine, we have the induction or injection of a fuel air mixture into the combustion chamber. Okay, first procedure, we have to inject a fuel air mixture. This is a basic working, just know what is it. So the fuel air mixture enters the cylinder, then after entering, the mixture is then compressed. The compression of the mix or the compression of the mixture is done. Then we give an ignition by spark plug or compression, and due to that the fuel gets ignited. or the fuel explodes. By the explosion, the cylinder, the piston is thrown downwards, thereby giving us the work. And the last procedure is the emission of exhaust that we observe in the silencer of a vehicle. That is the exhaust. The exhaust has to be removed from the combustion chamber. So these are the four processes that takes place inside the combustion chamber. Next is the EC engines or external combustion engines. External combustion engines, by the name itself, you know that combustion takes place externally from the automobile or the locomotive. So steam engines are the common examples of an EC engine. There is another engine called a Stirling engine. It's almost the same working as a steam engine, but it is also an external combustion engine wherein the combustion of the working fluid occurs outside the vehicle. So you can see that in a steam engine, you can see the flame is given to the water. Okay, the water then boils, and while boiling, steam is generated, and due to the high pressure of steam generated, the piston moves to and fro, giving a rotational motion to the flywheel or the wheel, thereby propelling the vehicle. Okay, the combustion takes place outside, not inside the cylinder. So the piston is there is a piston given, but the piston is moving due to the due to the steam pressure. The pressure of the steam gives a mechanical energy work to the piston, thereby rotating the flywheel. So the water is boiled outside the cylinder. Okay, the water is boiled outside the cylinder. Such engines are known as external combustion engine or EC engines. So it is defined as, it is said that these engines keep the fuel and exhaust products separately. They burn fuel in one chamber and heat the working fluid inside the engine through a heat exchanger or the engine valve. Okay, the working fluid is steam, wherein the steam is generated by boiling of water outside the cylinder and then transferring the working fluid to the piston, thereby producing mechanical work. Such engines are known as EC engines. Common examples are steam engines and another engine called Stirling engine, which you can check in the internet and you can know what type of engine is a Stirling engine. Next engines are reaction engines. So a reaction engine is nothing but a rocket engine or a jet engine. So here what we do is we combust the fuel and we produce a jet or a propellant that gives us the to and fro motion. Okay, we'll be given a thrust motion. We'll be propelled in the forward direction against the burning of the fuel. Okay, the fuel is burned and thrust outwards, giving us the thrust in the forward direction. Such engines are known as reaction engines. Common examples are jet engines and rocket engines. Next is an electrical engine. These engines converts electrical energy into mechanical motion. Common examples are electrical cars, electrical locomotives. So they convert the electrical energy stored either in the form of battery or given as powered through power lines, and that energy is converted into mechanical motion of the vehicle or the locomotive. Such engines are known as electrical engines. So they use motors to produce the mechanical work. So the current is given to the motor, which turns the wheels or the rails of the locomotive. So that is why a motor is shown here. So a motor is the basic mechanical component of the electrical engine. Next are physical engines. So physical engines, I have shown you a few examples. So these energy use the stored mechanical energy. Sorry, these engines use the stored mechanical energy to function. Examples are trebuchets and battering ram, which you have seen in movies and all, used in old times for war purposes and all. They use physical laws. That is, they have a spring or a weight which propels the projectile to move in the forward direction. So these energies are stored in the form of potential energy. Even examples are toy cars, which we can, when we run it backwards, it stores energy, and when you release it, it moves in the forward direction. Such engines are called as physical engines. They do not have much efficiency, and it's not used commonly, but for smaller purpose, they have been used as physical engines, and they are conventional engines. Now, we will see what are the parts of the IC engine. So we have to learn about internal combustion engines. So basically there are few parts in the IC engine or the internal combustion engine. And basically these parts can be divided into three parts or divided into three categories. So when you take an engine, at the topmost side we have engine head. We have the engine head. Then in the middle section we have the engine block, and last we have the oil sump. Okay, three parts. Basic, it is divided into three parts: engine head, engine block, and oil sump. So what are the parts found in engine head? In an engine head, you have head gasket, intake and exhaust port, inlet and exhaust valves, spark plug or fuel injector, and camshaft. Okay, these are the basic parts of an engine head. So what is the function of an head gasket? So you can see an engine head in the picture, and the gasket is the red part shown as head gasket. You can see it is labeled there. It is called as head gasket. So a gasket's role is nothing but to provide a sealing action. That is, when you have been supplying air and fuel inside the cylinder, the air and fuel must not leak upwards. That is, it must not go out from the engine block or the cylinder to the atmosphere. Okay, it must not move outside. So for that purpose and for a sealing action, a head gasket is given. That is in between engine head and engine cylinder block. So a gasket is provided in between engine head and engine cylinder block. Next, intake and exhaust ports. So intake and exhaust ports are nothing but intake port inhales or gives in air to the cylinder, while exhaust port releases, or the exhaust is carried out from the engine to the atmosphere through the exhaust port. They are nothing but holes provided inside the engine head. Next are the inlet and exhaust valves. An inlet valve is responsible for providing the inlet of air or fuel. Air or air fuel mixture. In diesel engines, air is injected into the engine, while in petrol engines, air and petrol. There is a mixture inside, and that mixture is applied into the engine. Okay, so for that purpose, for the inlet purpose, the inlet valve controls the entry of air or air fuel mixture. Okay, they control the inlet of air fuel mixture. Then comes the exhaust valve, which controls when the exhaust has to be gone out from the cylinder. Okay, there are basically 4 strokes in an engine, and in that strokes the exhaust is carried outside the engine, and the controlling for controlling the exhaust, an exhaust valve is provided. Next is a spark plug or fuel injector. In case of petrol engines, a spark plug is given which provides a spark for igniting the air fuel mixture inside the cylinder, thereby giving the power required for the mechanical work to be done. Then comes the camshaft. Camshaft controls the opening and closing of valves. So a camshaft is provided for inlet valve and exhaust valve. Okay, what is your time for this hour? Am I audible?
Yes, sir.
Okay, what is your time for this hour? I think it's 12:10, right?
Yes, sir. Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Okay, we'll wind up this class for today. Okay, as a homework, I would like you to look up these things. First one is hybrid vehicles. Then comes ion drive. Then is EM or CAN drives. Then some of the electric cars found in India. So in tomorrow's class, I will ask a few persons about these topics. Please refer this. I just want what is the few electric cars or what is an hybrid engine or an ion drive. So these are few of the technologies that are present in the current scenario of automobiles. So I would like you to refer these things, and I will ask upon tomorrow's class. Now let's take the attendance. Advaita Eke. It's Advaita, right? Advaita Eke. Advaita Eke.
Present, sir.
Okay. Ajay Krishna.
Present, sir.
Agil K.
Present, sir.
Akshay Krishna.
Present, sir.
Akshay Krishna T. It's Akshay Krishna T, right?
Message it,
Akshay.
sir.
Okay. Akshay Rajivan.
Present, sir.